Before we can calculate Kp, the equilibrium constant with respect to pressure, we have to be able to calculate a mole fraction and a partial pressure. If you imagine that you're calculating an equilibrium constant for a gas, it is entirely possible to calculate a Kc. We need to know the total volume of the container, and we need to know how many moles of gas there are. And that sounds nice and simple, but actually there are some practical difficulties with doing that. So actually, quite a lot of the time it's easier to use Kp, which is related to pressure rather than concentration. In the case of Kp, we actually don't need to know the volume of the container, and that's quite useful. So it can be a lot simpler, and to do that we need to work out a mole fraction. Now what a mole fraction is if you take this cylinder here, you can see I've got some blue, some green and some red dots. Blue, green and red representing gas particles. Obviously there are more particles in reality. So let's say that each dot represents 0.1 mole of gas. Okay? So first of all, let's count the number of moles. Now in reality, if I was making this cylinder, I would be measuring it as I put in how much moles have I put into the container. Would be something I could take off the instrument that I'm adding the gas through. But if we just count the picture for now, we've got 2 particles of red. Now I said each particle is worth 0.1 moles, so I'm going to say that there are 0.2 moles of red gas in this container. If we take the blue, that one, we have 4 particles drawn, which I'm going to say represents 0.4 moles of gas in this container. Now, if I then take my green, 1, 2, 3, 4, 5, 6, I'm going to call that 0.6 moles of gas in that container. Mole fraction is the proportion of the number of moles of gas, of a certain gas, divided by the total number of moles in the mixture. So if I was to look at the red one, the mole fraction of the red gas would be the number of moles of the red gas present in the mixture, which is 0.2, and it would be divided by the total number of moles of gas. So the total number of moles of gas in this case is 1.2. So if you take a fraction of each gas, the total fractions should add up to 1. Okay. So if we take the mole fraction of red, 0.2 divided by 1.2, that would give us a mole fraction of 0.167. And then if I do the same for blue, 0.4 divided by 1.2, that would give us 0.3. And then for the green, 0.6 over 1.2 would give me 0.5. So if I add all of these up, we've got 167 plus 333, then that adds up to exactly 1. Okay? So that's a little check you can do to make sure that you've done your mole fractions right. Everything in there added together should equal 1. Partial pressure is calculated by taking the mole fraction of a gas and multiplying it by the total pressure. So what that means is if I take my sample of gas and I extract from it just the red gas, then you can see that the pressure in this version of the container is going to be much, much lower because it's got fewer particles. It's only got the red ones in, so that's going to give us a lower pressure. If I take out only the green ones, this one is going to have a lower pressure than the mixture as well. And if I'm going to take out only the blue ones, this will have a lower pressure than the mixture as well. But because the total number of particles in all three of these is the same, if we were to mix these gases again and put them back into an identical container, we would get the total pressure again. So let's imagine that the pressure here is 4 atmospheres. The mixture as a whole is at 4 atmospheres pressure. If I have a sixth of the particles, that's the red one, that's a sixth, then we multiply a sixth by the total, then we are going to get a value of 0.667 for our partial pressure. And the partial pressure, because this was in atmospheres, then this unit here is atmospheres. So 0.667 atmospheres of pressure are due to the presence of red particles in this mixture. If we then do this for the blue, we've got a third of the particles are blue, so a third of the pressure of 4 atmospheres is going to be due to blue particles. So a third times 4 atmospheres gives me 1.333, and then finally, if we take our green particles, that was half of the particles were green, so half of the pressure is due to green, and therefore that's going to be half of 4. Okay, and as we can see, if we take the fraction here, 667, that's 333, add those two together, that makes 1, and then we add that one together, that's 1, and then we add those two, that gives us a total of 4, which is equal to the total pressure at the top. And that's how we'd calculate a partial pressure and a mole fraction.